Welcome back to our second video about algebra of functions. So in our first video, we talked about what a polynomial is and some definitions that go along with those polynomials. But in this video, we're going to be playing around with those polynomials. We're going to do some operations on them. So the same way that we have 4 basic operations with numbers, we have those same 4 basic operations with polynomials as well. So we define a polynomial as an expression, but that expression can define a function. So if we were to add 2 polynomials together, it would look maybe like f of x plus g of x. You can do that same with subtraction, f of x minus g of x. You can do that multiplication, f of x times g of x. And then division, you might see f of x divided by g of x. You might also see f of x over g of x. Right, the same way we do with numbers. Before we jump into doing these operations on polynomials, I wanted to recall just a couple of quick tools that we're going to be using throughout this video. So the first is that distributive property, right? So remember, if we take a and multiply that by the sum of b and c, I can distribute that a into both b and c. So it would look like a times b plus a times c. We're going to see that coming up a lot with the multiplication of polynomials. Other thing we need to remember how to do is how to combine like terms. So for instance, if I had a polynomial like 2x minus 3x squared plus 5x, right? The two like terms here, the 2x and the 5x, because they have the same variable part. They're not similar to that 3x squared, even though all of those terms have x's, the x squared is distinct from just the x. So here we would just combine that 2x and 5x to get 7x and leave that negative 3x squared alone. All right, let's play around with doing these operations on some polynomials. So we'll start with addition and subtraction. Let's go ahead and give ourselves a couple of examples of polynomials. So let's let f of x be x squared plus 2x plus 1. And we'll let g of x be x cubed minus 5x plus 7. We'll go ahead and start with that addition. So let's consider f of x plus g of x. So anytime we see that function notation, we can replace it with the polynomial that's defining that function. So in place of the f of x, I'm going to write in that x squared plus 2x plus 1. And in place of that g of x, I'll write that x cubed minus 5x plus 7. And you'll notice that I put the polynomials into parentheses. That's just a good reminder to say I want the entirety of f of x, and I'm adding in the entirety of g of x. In the case of addition, those parentheses aren't actually going to do anything, right? These parentheses aren't changing that, I'm just adding all of these terms together. So from here, I can combine all of my like terms. A way that I prefer to organize these is I'll just start with the highest power that I see, and I'll work my way down. So let's go ahead and start. We can see that x cubed is the largest power that we see, and it's the only one, so we'll leave that x cubed. We also see that x squared, it's again the only one, so I'll add in that x squared. But now moving down just to the x, right, I have that positive 2x and the negative 5x. So I will combine those to get that negative 3x. Then similarly, that 1 and that 7, I'll combine to add an 8. All right, subtraction is going to look really similar. So now let's consider f of x minus g of x. Again, we're going to do that same exact thing. We're going to replace that function notation with the polynomial itself. So now I'm going to have x squared plus 2x plus 1. I'm going to subtract x cubed minus 5x plus 7. Now in this subtraction, those parentheses are actually super important, right? I want to subtract all of the terms from g of x. So let's go ahead and distribute that minus sign. So we still have the x squared plus 2x plus 1. Now we're going to subtract the x cubed. Subtracting negative 5x, that means we're going to add in that 5x. And then subtracting that 7. And then from here we do that same thing. We're going to combine our like terms. Again, I'm going to start with the highest power and move my way down. That x cubed is now negative, so I'll have that negative x cubed out front. I'll add in that x squared. Again, I'm going to combine my 2x and 5x, but now that that 5x is positive, I'll end up with a positive 7x. And lastly, that 1 and that negative 7 will combine to a negative 6. Okay, let's move on to multiplying those polynomials. We'll give ourselves some new examples of polynomials. Let's go ahead and actually just pick 2 linear functions, right? All linear functions are polynomials as well. So let's let f of x be 3x plus 2, and we'll let g of x be x minus 1. So again, we just want to look at taking f of x times g of x. So I'm going to take those function notations and I'm going to replace them with the polynomials themselves. So I'll do 3x plus 2, and I'll multiply that by x minus 1. And in this case, these parentheses are, again, super important, just like they were with subtraction. So from here, we're going to actually use the distributive property twice. So the first time we use it, we're going to treat that 3x plus 2 kind of as that a in that definition, that example from the beginning. I'm going to take it and distribute it to both the x and the negative 1. So what that'll look like is I'll take that 3x plus 2 and I'll multiply it by x. And I'll add into that, taking that 3x plus 2 and multiplying it by the negative 1. From here, we're going to use that distributive property the second time, right? But now, for instance, with this first product, I'm going to take that x and I'm going to distribute it to the 3x and to the 2. So I'll get 3x times x plus 2 times x from that first term. And from that second term, I'll get 3x times negative 1 and 2 times negative 1. Now we want to simplify each of these, right? Remember from that exponent section, 3 times x, that'll be a 3x squared. Then I'll have plus 2x, I'll have minus 3x, I'll have minus 2. Then that last step, we want to always combine all those like terms, right? I see two terms that have just that x, that 2x and negative 3x. So combining those, I'll end up with 3x squared minus x minus 2. And you can repeat this process with any number of terms for your polynomials. It'll end up turning out pretty similarly. Just remember that you're kind of doing that distributive property multiple times. The last operation you'll see is division. We're really not going to delve into division too much in this class, but I'll show you at least what it would look like. So for instance, if I kept that f of x equals 3x plus 2, and that g of x equals x minus 1, if I was going to divide them, if I took f of x over g of x, again, just replacing that function notation with the polynomials, I'll get 3x plus 2 over x minus 1. So you might have noticed with all the other operations, when I add, subtract, and multiply polynomials, I get back out another polynomial. I get back to that same place. When I divide polynomials, I end up somewhere different. And if you remember from that first video, when we saw examples of things that aren't polynomials, anytime we divided polynomials, it's no longer a polynomial. So that's why we're not going to delve too much in this class into that division. It's because we get out something that's different from what we're actually looking at in this section. All right, that wraps up all those operations we can do with polynomials.